Okay, class, welcome to the next math lesson. Still in Module 1. Module 1, this is Lesson 4, all about what we will call the zeroth power. And so today, after we finish our notes, which I hope you're following along with your own notes, you will be working on pages 36 through 41 of your module book. So let's start with the rules we know. We have been studying exponents for about a week now. Let's talk about rules we know. The first lesson was all about exponential form. So you had a base with an exponent, and this means that you had x times itself n times. That was lesson 1. Lesson 2 showed us this, is that when we multiply the same base with two different exponents, we can add the exponents. And also, when we divide the same base with different exponents, we can subtract the exponents. We also learned in lesson 3 about the rules of exponents with parentheses. We learned that if you have a base raised to a power and then raised to a power, looking like that, you multiply the exponents. And another rule with parentheses, we saw that when we have two bases inside parentheses and an exponent outside, the exponent gets passed to both of them. That works when the two bases are multiplied by each other. And when the two bases are divided by each other like this, the exponent still gets passed to both of them. So those are the 6 things we've learned so far. Now this works for most values of x and most exponents. There are a couple things you have to think about, specifically for these bottom ones right here. These rules do not work if this x is 0, because it is impossible to divide by 0. And so this one does not work if y is 0 for the same reason. You cannot divide by 0. But for all other numbers, this holds true, except for 0. If this is 0 or this is 0, it does not work. But there is an odd exponent rule that we're going to talk about. It does involve 0, but what about if the equation has a base and the exponent is 0? What happens when the base has an exponent that is 0? For example, something to think about. 2 to the 0. 2 to the 0. This is a 2. I know it might look like a z, it's a 2. What does that equal? What do you think? Take a minute. You can pause the video if you want. Think about what you might say it equals. Most people, or a lot of people, will say that 2 to the 0 equals 0. But does that work? But does it? That's what some of you might have said. That's what a lot of people say. But does it? So let's try. Let's do it. Let's do this. Let's pretend if 2 to the 0 does equal 0. Let's use a problem. And let's say if 2 to the 0 equals 0, and we have 2 to the 0 times 2 squared, if this is the problem, and you say 2 to the 0 equals 0, then this should be 0, and this should be 2 squared. And 0 times 2 squared is 0. Okay, so if 2 to the 0 equals 0, the answer to this is this. But what about if we go back and we use the first rule that we learned in lesson 2? Here it is right here. X to the m times x to the n equals x to the m plus n. Let's use that rule for the same problem. For the same problem, we have 2 to the 0 times 2 squared. And this time we're going to follow the rule and add the exponents. 0 plus 2 is 2, and 2 squared is 4. Obviously, there's something wrong here because the same expression cannot equal 0 and 4 like that. So either the first rule is wrong or 2 to the 0 equals 0 is wrong. The rule or this has to be wrong. Well, this is what's wrong. 2 to the 0 does not equal 0. In fact, 2 to the 0 does equal 1. In fact, not only does 2 to the 0 equal 1, but 5 to the 0 equals 1, 7 to the 0 equals 1, 54 to the 0 equals 1. In fact, our rules is that anything to the 0 power is 1. Anything to the 0 power is 1. Let me show you why real fast. If you needed to copy down your notes, pause the video, catch up on the notes. But I need to move to a new page. So let's look at why. Here is why any number to the 0 equals 1. I'm going to show you the example with two different numbers. Let's start with 2 to the 5th. 2 to the 5th, 2 times 2 times 2 times 2 times 2. 2 to the 5th equals 32. 2 to the 4th, 2 times 2 times 2 times 2 equals 16. 2 to the 3rd, 2 times 2 times 2 is 8. 2 squared, 2 times 2 is 4. 2 to the 1st is 2 equals 2. So now we get to the bottom here, 2 to the 0. So let's look at the patterns that you see emerging right here. On this side, you will see that the exponents are counting down by 1. We have the exponents are doing -1. What is happening to the products on this side? So when the exponents -1, the products you should see are dividing by 2. That's the pattern. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. So 2 to the 0 is 1. And it works for all of them. It works for all numbers. Let me show you with what else might be easier to do. Let's just do 5s. Let's do 5 to the 4th because that might be the highest I can go. 5 times 5 times 5 times 5. 5 times 5 is 25. Times 5 is 125. Times 5 is 625. 5 to the 3rd is 5 times 5 times 5 equals 125. 5 squared is 5 times 5, 25. 5 to the 1st is just 5. 5 to the 0 is 1 because you see the same pattern. Follow the pattern as it moves down. The exponents are doing -1. The products this time are dividing by 5. So the next step is 5 divided by 5 makes 1. So that is why the rule for today is that any number x variable to the 0 equals 1. That is the rule for today. Any base to the 0th power is 1. Any base to the 0th is 1. Let's see how we can use that on a few different exercises, starting on page 36. So we're actually going to skip exercises 1, 2, 3, and 4 and go straight to exercise 5, because that will show you how we use the 0th power to write numbers. Specifically, we're getting ready for scientific notation, a different way to write really large numbers. So it says right here, write the expanded form of 8,374 using exponential notation. Now, you have probably used expanded form before 8,374. The expanded form you've seen before might look something like this, where your teachers in elementary said, this is 8,000 plus 300 plus 70 plus 4. Now that is expand form, but we need expand form with scientific notation. So to do this, we break the numbers up even further. 8,000 is 8 times 1,000. 300 is 3 times 100. 70 is 7 times 10. And 4 is 4 times 1. So that is breaking up even more, but still we don't have exponents. We want exponential notation. It says it right here, exponential notation. So I better see some exponents here. So the way we use exponential notation is with numbers, we use tens. Because we use base tens, we can use tens. So for example, 1,000 is actually 10 cubed, 10 to the third. So 8 times 1,000 can be 8 times 10 to the third. And 100 is 10 squared. So we do 3 times 10 squared. And 10 is 10 to the first. So we do 7 times 10 to the first. And this is 4 times 1. Well, how do we use exponents with 1? Remember, we just learned the rule for today. We're using tens, so 10 to the 0 is 1. And this is expanded form with exponential notation, where I stretch the number out and show you the place value using exponents and tens. This is the thousands place value, 10 to the third. 10 squared is the hundreds place value. 10 to the first is the tens place value. 10 to the 0 is the ones place value, because 10 to the 0 is 1. So there you go. That's how you write with exponential notation. It will come in handy later, so make sure you know how to do it. To test how to do it, try out on your own exercise 6 right now. It's a long one. 6,985,062. Do it just like I did exercise 5. Pause video, try to stretch it out, and show me exponential notation. Come back and we will check it. Okay, I'm back. Hopefully you pause the video and you see you're ready to check the work that you did. That's our number. Let's break it up into the expand form you learned in elementary school, where this big number is 6 million plus 900,000 plus 80,000 plus 5,000. I'm going to skip the hundreds because I have a 0 in the hundreds, so I don't need to worry about that. Plus 60 plus 2. Now I'm going to separate it into place values. So 6 million is going to be 6 times 1 million. 900,000 is 9 times 100,000. 80,000 is 8 times 10,000. 5,000 is 5 times 1,000. 60 is 6 times 10. And 2 is 2 times 1. Now I'm going to take those place values and turn them in. I have 6 millions, 900,000s, 8 10,000s, 5,000s, 6 10s, and 2 1s. Now to make exponential notation, I take these place values and write them like exponents. So this is 6. 1 million is 10 to the 6th. I know because there's 6 zeros. 9 times 100,000. 100,000 is 10 to the 5th because there's 5 zeros. 8 times 10,000 is 8 times 10 to the 4th because there's 4 zeros. 5 times 1,000 turns into 5 times 10 to the 3rd because there's 3 zeros. 6 times 10 turns into 6 times 10 to the 1st because there's 1 zero. And 2 to the 1st turns into 2 times 10 to the 0. Because remember, 10 to the 0 is 1. 10 to the 0 is 1. Hopefully you got that. If you did not, make sure you check yours and ask for help. Okay, moving on to some practice. Let's look at the exit ticket real fast. Your exit ticket for the day only has 2 questions on it. The first one says, simplify the following expression as much as possible. So what I'm going to do is this is 2 numbers multiplied by itself. I'm going to separate them. I'm going to have 4 to the 10th over 4 to the 10th times 7 to the 0. I'm going to do both parts separately. Now, you know, following the rules we learned, that 4 to the 10th divided by 4 to the 10th is 4 to the 10th minus 10, following the rule. Right now, let's just leave 7 to the 0 as it is. 10 minus 10 is 0, so this turns into 4 to the 0 times 7 to the 0. And using the rule we learned today, anything to the 0 is 1. So this is 1 times 1. So our final answer is just going to be 1, and that is simplified as much as possible. For the next question on the exit ticket, number 2, we need to use the distributive law and then the definition of the 0th power to show that both of these, that expression and that expression, are equal. So let's start by finding the solution to this expression. A to the 0 plus b to the 0 all times a to the 0. Now it says it wants me to use the distributive property. So distributive property means the a to the 0 on the outside gets passed to everything on the inside. So this a to the 0 joins that a to the 0. I get a to the 0, a to the 0, plus a to the 0, b to the 0. This got passed to both. Now, using our rules, I know that both these bases are the same, so I can add the exponents. These bases are different, so I leave them alone. 0 plus 0 is 0, so I get a to the 0 plus a0, b0. Now I use the rule we did today. A to the 0 is 1. This a to the 0 is 1. And b to the 0 is 1. 1 times 1 is 1, and 1 plus 1 is 2. So this expression equals 2. Let's check it with the other expression and prove that they are equal. So this one has a to the 0 plus b to the 0, except for this time, b to the 0 is outside the parentheses. But remember, it still gets passed to both on the inside. So this time the b0 gets passed over here, so I get a to the 0, b over 0. And the b to the 0 gets passed here, so I get b0, b0. Now, I can't, on this side, I can add the exponents because the bases are the same to give me 0 plus 0 is 0. This side, I cannot add them together because the bases are different. So that stays the same. But now I can use the rule we learned today. A to the 0 is 1. B to the 0 is 1. Plus b to the 0, another 1. 1 times 1 is 1. 1 plus 1 is 2. These are the same, and that's how you prove it using the distributive property and the zero property. A little bit tricky, I know, but don't worry about it. You're going to do well. Just take your time, ask for help if you need some help, and go step by step. Rewind the video if you have to. Send me a message for a private meeting if you need some one-on-one time. You also have the homework helper on the next page that will help you summarize the learning from today. Use the homework helper, look at it. It does explain things and give you 6 more examples about how to use the zeroth property. And then when you're ready, after the homework helper and practice, work on the problem set. Try the problem set yourself right now. Pause the video for a little bit, and then come back ready to check the answers for this. Okay, so you should have paused the video. You should have done all 5 on the problem set, ready to check your answers with mine. So y to the 12th divided by y to the 12th. Well, I see both bases are the same, and this is division. So I know when both bases are the same and it's dividing them, I can just subtract the exponents. 12 minus 12. That makes y to the 0, and I learned today, anything to the 0 always equals 1. For number 2, what you should remember is, might look a little bit tricky. It's really not, because you just have to remember if when you multiply fractions, you just need fractions. So just turn this first number into a fraction, divide by 1. Dividing by 1 doesn't change anything, except it makes it a fraction so we can see how to do it. Because now that we have 2 fractions, I know I can just multiply straight across. 9 to the 15th times 1, and 1 times 9 to the 15th. And just like example 1, I know I can subtract the exponents because it's dividing of the same base. 15 minus 15 is 0, which today I learned 9 to the 0 is just 1. Number 3 looks super confusing, except it's much simpler than it looks, because if you look at this, all of this stuff is inside parentheses. So all of this that I'm underlining right now, that is just a base. Yes, it is a big base. It is a complicated base, but it is still a base. This 0 right here is the exponent. So I have a base to the 0 exponent. And we know anything, even if it's super complicated, to the 0 is always 1. Kind of a trick question. Number 4, I want to spread out a little bit, so I'm going to go down to the bottom of the page and do number 4 with you. We have 2 squared times 1 over 2 fifths times 2 fifths times 1 over 2 squared. Now, the first thing, remember, I'm going to tell you, when we're multiplying fractions, we just need fractions. So I have 2 things that are not fractions. Make them fractions. Just put a 1 underneath. Dividing by 1 does not change anything, but it makes it super easy to do. So change to fractions. And then you're going to, because it's all multiplication, I can use the commutative property. I can put the numbers I want to next to each other. So for example, this one on the end, I'm going to move it to the front. And the reason why, if it's not obvious yet, will be obvious in a second. Because now, look at these. These match. So what I want to do next is I want to use the associative property to make groups. And those are my groups. Because if I do this group first, I get 2 squared. Remember, multiply fractions go straight across. I get 2 squared over 2 squared. And then this group, multiply straight across, gives me 2/5 over 2/5. And then I use the rules we learned last week. This is dividing, and the bases are the same. So I can just do I just subtract the exponents. Same thing right here, dividing with the same base, subtract the exponents. That gives me 2 to the 0 times 2 to the 0, which is, remember, anything to the 0 is 1, so I get 1 times 1. 1 times 1 is 1. So number 4 also is just 1. I wonder what number 5 is going to be. Number 5, I'm also going to do down at the bottom to spread out a little bit. So number 5, I get x to the 41st over y to the 15th times y to the 15th over x to the 41st. Now, hopefully you know that I just multiply straight across, so I get x to the 41st times y to the 15th, and I get y to the 15th times x to the 41st, because I just multiplied straight across. Now I'm going to use that commutative property again right here, and I'm going to put the x's on top of each other and the y's on top of each other. Now I'm going to use the associative property, and I'm going to make groups right here. So I get x to the 41st over x to the 41st times y to the 15th over y to the 15th. You see where this is going, I hope, because you see, dividing the same base, so just subtract the exponents, which gives us 41 minus 41 is 0, 15 minus 15 is 0. I get x to the 0 times y to the 0. I ran out of room on the bottom of my page, so I'm just going to go sideways. X to the 0 is 1, y to the 0 is 1, 1 times 1 is 1. So all questions on the problem set equaled 1. This was some good practice using our all the rules we learned last week. Please keep doing the practice. Try your best. Rewind the video. Check it again. Make sure you know how to do these things before we move on till tomorrow. If you have any questions, please send me a message. I'll be happy to help you. Have a good day, and I'll see you tomorrow.